let me say that nothing is put on Canvas so far. So after this class, I'm going to post everything on Canvas, including the syllabus, right? So you don't really need to write anything down as far as the syllabus goes. But you might want to write down my email address just in case you don't see anything by tomorrow morning. You can email me and I'll enroll you in Canvas. It happens every once in a while that you don't get automatically signed up for Canvas. Yeah. You can't? Is that better? No? Why can't? Because I'm mumbling or not loud enough?
Maybe you can move it a little farther from your mouth. Like in the second button. Just making suggestions.
Is that better?
Yes.
Okay, good. All right, so I was saying that this syllabus is going to be posted on Canvas, but the only thing you should write down is your email address in case you don't get access to Canvas for this course, which happens every once in a while, right? But otherwise, I think for most people it'll be on Canvas, and you'll see it after this class, a little while after the class. So this is College Physics 1, right? So everyone is in College Physics 1, right? Okay. So we always meet in this room for tests and for the final and for class, obviously. So it's always from 7:10 to 9 p.m. in this room. About 15 minutes into the lecture, give or take 5 or 10 minutes, you'll have a 10-minute break, about 15 minutes in. So actually this syllabus is kind of long, so after I'm done going over the syllabus, is about time for the break. So that's when you have your first break, is when I'm done explaining the syllabus. So my name is Dr. Gross, and my office is in the building behind here, the science building, 118. And down the hall from me is the physics office, which is 108. That's where my mailbox is. It's also where the mailboxes are for your TAs for the labs as well. So if you need to go to the mailboxes for me or your TAs, it's down the hall from my office in SC 108. By the way, the labs do not start this week. They start next week. Okay. So that's where the mailboxes are. That's where my office is. And I don't have a phone, but my email address is rgrossfun@fau.edu. I get a lot of emails, and sometimes I don't see emails. So I try to get back, but if I don't, just email me again. I don't mind multiple emails, right? But that's probably the best way to contact me, or after class or during the break. Before class, by the way, I should mention I teach the same course, a different section of it, in SO 250, from 5 to 6:50. So I always run from that building to this building, right, to teach. So before class, I don't have much time, but after class, I usually do. What was I going to say? The other thing is you could go to the other section if you can't come to this section. The only thing is you have to take the exam in this section, which is probably better because it's later anyhow. But either section you can go to, it's fine. The other room really isn't that great, though. I like this classroom far more than I like SO 250. SO 250, the acoustics in there are horrible. But anyway, you could go to SO 250 for the other class at 5 o'clock. So these are my office hours. So on Tuesday, it's from 1 to 3, obviously in my office. From Wednesdays, it's 2:30 to 3:30, and on Thursdays, it's 2 to 4. And if you can't make it during any of those times, you can email me or see me after class or during break or something and try to set up something outside of those times. Okay, so the review session, I'll go over what that is as we get further on in the syllabus, but I do have this thing called a review session, which I'll explain later. It's from 4 to 5 p.m. in SC 319, which is the same building as where my office is. It's the building out this way, adjacent to this courtyard here. But it's on the third floor, right? So it's 319 on the third floor. And there's like 319. So it's 319A, right? You want to find 319A when you come to this review session if you come. The SI obviously introduced herself and handed out her hours, but the hours are here too. Eventually, I'm going to have TAs, which will provide some tutoring as well. I don't know who they are now. I'll know later on. Probably next week I'll know. And I'll send out an announcement at Canvas what their hours are. Actually, what I'm going to do, when I have everyone's hours, my TA's hours, I'm going to make a calendar and post it on Canvas so you can see when all the times are for everything, including the SI sessions and everything. So everything in this course is done through Canvas. There is no book, which I'll explain in a minute. But so you have to be on Canvas. This is why I say you should write down my email address. Make sure you're on Canvas by tomorrow morning, say. So basically, yeah, like everything so basically, I have PowerPoints. All the PowerPoints are going to be on Canvas. Everything I write, so I use a tablet. I write on the screen. Everything I write is going to be in a PDF that's posted on Canvas. You'll have homework and quizzes. That'll be on Canvas, right? So everything is on Canvas. The only thing that really isn't on Canvas is the tests, which are obviously in class, right? But everything else is via Canvas. So you have to be on Canvas for this class to work. You also have to check Canvas, to make sure you're up with everything in this class as well. So like I said, I don't use a book. There are various reasons why I don't use books. I just don't like books. I mean, they're too expensive, and I don't know. I don't like the way book companies operate nowadays. So I haven't used a book in quite a while. But the good news is that this is physics that's been done the last 300 years. I mean, physics changes, but not the physics we're doing. This is the basic physics, which hasn't really changed at all in hundreds of years. So basically what I'm saying is if you want additional material, another source of physics, you can get any sort of used algebra-based physics book. It'll work. The thing I recommend if you want extra problems or something is this thing here called the Shams Outline. So Shams Outline is a whole series of books. It's not just physics, it's chemistry, biology, math, everything. I don't know how many they make, probably like 100 of them. But the one you want to look at is obviously the one for physics, college physics. It's the algebra-based one. And what it is, it's basically a bunch of problems, worked out problems on college physics. It's cheap, probably about $20 on Amazon new. I mean, if you find it used, it's probably even cheaper than that. So it's a good resource to have for extra problems, right? It's also good for other classes. Like I said, they make them for biology, chemistry, organic chemistry. I don't know what sort of biologies, but they have a whole bunch of subjects in them. Advanced levels, too, graduate courses also they have Shams outlines for. But anyway, look for the college physics one. You can Google it on Amazon or go to Amazon and see if you can find it, right? All right, so does everyone understand how the book works, right? You don't need one. The book is basically the notes and the PowerPoints and the homeworks and everything, right? That's the book, right? Okay. So, all right, so we need the prereqs on here, but there's something weird with the prereqs. So one of the prereqs is calculus, right? There are methods of calculus, which is sort of calculus. But does anyone here not taken trigonometry? Yeah, there's always a few. Yeah, so that's really what you need. You don't really need anything in methods of calculus, but for some reason, that's still a prereq. Even though I've been trying to change it for trig instead of calc, but so you do need to know some trig in this course. However, we'll be going over the basic trig you need to know for this course today after I go over the syllabus, right? So, yes?
It's been exactly 3 years since I've taken trig, so how in depth are we going to get?
Well, any trig is better than nothing, right? So some people have not had any trig. But I'm going to go over the trig that you need to know for the course. And hopefully you can pick it up if you haven't seen it yet today or this week. And then we start using it actually pretty soon in the context of physics. So, all right. Well, anyhow, we'll see how that goes, right? Just see how the first week goes here. All right, so the scope and objectives, so basically it's the same thing you do. So any school you go to and take a first semester physics course, it's the same thing. Whether it's a calculus-based course or an algebra-based course, the topics are the same. How you do them are different in the calculus-based and algebra-based. But it's just basically how, Newton's law. It's basically how things move. So basically we figure out how things move, how things slide, how things roll. We talk about this thing called work and energy and torque and angular momentum, all this stuff, momentum. It doesn't really matter, right? Throughout this course of the semester, you'll learn this stuff. But this is the basic, typical things that are addressed in this course. All right, this is sort of important. If you have any sort of disability, either physical disability, learning disability, you can go to the, what is it called now? They change the name every once in a while. Student Accessibility Service Office, and sign up there. And they allow you to take the test over there instead of in class if you need to do that. You need to do it like this week because it takes a few weeks to go through, right? So if you need any help with that, contact their office. Their number is here, right? And their office is SU 133. All right, so, and there's this too for students who need it. Okay, so the grading is based on basically two things, although technically it's three things. No, almost, well, 3.5 things. So there's going to be homework, but the homework I decided I changed it. It used to be part of your grade. It used to be factored into your grade, but last semester I changed it to be extra credit added to your test scores. So I'm going to keep it that way because it seemed to work out pretty well last semester. People seem to like it. So the homework is extra credit. If you do it, you get points that'll be added to your test, right? That's how homework works. But you should do it because it helps making the test easier. That's the whole point of homework. Makes things easier if you do it. There'll also be quizzes. I'll go into exactly how these quizzes and homeworks work as I go further on in the syllabus. Right now, I'm just telling you they're waiting. So, but the thing that you're really graded on throughout the semester is quizzes and tests, right? So how they're weighted, how they factor into your grade is a little bit strange. So basically, you have a quiz average, you have a test average. So basically, on an individual basis, if your quiz average is greater than your test average individually, then I count your quizzes more in some sense. Your quizzes are 20%, and your tests are 65%. But if it's the opposite way, or if your test average is higher than your quiz average, then it's opposite. The quizzes are counted less, and the tests are counted more. So the tests are 70%, and the quizzes are 15% for that case, per student, right? So I look at everyone one at a time. And then if you choose to take the final is actually optional. I'll get into that too when we get to the final. It's at the very end of the syllabus. But it's 15%. But the point is, don't worry about that. Up until the end of the semester, you need to worry about the quizzes and the tests. Correct? Those are the things. And also do the homework because it helps, right? And the lowest two quizzes will be dropped. So the lowest. If you either don't do the quiz or you do all the quizzes and I dropped the lowest too, right? But they're also zeros if you don't do them.
How many points extra credit is each homework?
It varies, but each test will be something on the order of like 10 points if you do all the homework for that particular test. Something like that. Around 10, give or take. All right. This is the test schedule. It's tentative. See this word before the exam schedule, tentative. So things can change. So I wouldn't schedule a vacation on September 13th because I might move the test ahead to maybe later date, right? So if everything goes perfectly though, these are the test dates, right? So the first one should be September 12th, the next one should be October 10th, and then October 31st and November 21st. So it's 4 tests. That's the main thing, right? You're grade on 4 tests. You should try to do well in all of them, but there's 4 of them. So if you don't do great on one, you can still recover if you do well on the other ones, right? There's 4 of them. Okay, so that's the number of tests. The final, like I said, is optional, which I'll explain again when I get to it at the bottom of the syllabus here. But if you choose to take it, it's December 10th from 7 to 9:30 in this room, which I got to remember because this class usually starts at 7:10, so that always screws me up that it starts at 7, but whatever. However, although I doubt anyone in this class would do this, there's usually not that many people who take the final, and You can take the final with the other section if you want to, which is like December 5th, though. So I don't know if anyone will really want to do that. But you have the option of doing that, right? You could take it with the other section. The other section can take it with your section of the final, too. What was I going to say? No, that's what. Okay, so makeup exams are, it's a typical makeup policy. I think every single class has the same sort of makeup policy. If you have a legitimate reason to miss a test and you have documentation that backs up what you tell me, then of course I can give you a makeup test at some other date. And that's how makeup test works. It's typical for just about every class in on this campus. The other thing I want to mention quickly is incompletes. Some people ask for incompletes at the end of the semester because they're failing. They just want incomplete. They want to take the course again without getting any permanent grade on the transcript. But that's not how incompletes work. Incompletes are for if you're doing sort of well in the course and then like you have pneumonia and you can't come to school for 3 weeks. So you miss a chunk of the material and you can't. It forces you to get a poor grade because of the material you missed due to something else. Then you can get an incomplete and make up the material that you missed in some other semester. But you don't just get incompletes for failing the course, right? That's not how it works. So the withdrawal date, I don't know when it is. It's like almost at the end of the semester nowadays, right? So, if you're failing, just withdraw from the course, right? That's what you do. You don't ask for an incomplete. Oh, I know what I was going to say. You notice the last test is actually before Thanksgiving, like way before Thanksgiving. It's the week before Thanksgiving, right? So if you don't take the final, you're actually done before Thanksgiving, right? Not even after Thanksgiving, right? So I'll get to the final later, like I said, next later. But the point is, you just want to do well throughout the semester, and then you don't have to take the final, and then you're done on the 21st, correct? Which is pretty early. Unless some test has to be rescheduled for a hurricane or something, which could happen. Hopefully it doesn't happen. Okay, so this is just something, some ITs where we've actually going to have a weekly study session. Okay, so the homeworks are going to be given just about every week. You have homework. Now the homework's kind of hard. I make it hard because, I don't know, it's good to think about this stuff a bit, right? If everything's super easy, you don't really learn that much, right? You have to have something that's a little bit difficult from time to time. So the homework is hard. It's not going to be like, oh, this is straightforward. You have to think about it, and it's hard, but it's extra credit now, so that's the good thing. But if you do the homework and you get them right, then you get extra credit, which will be added to your test scores, right? So the way homework works, it's a little bit strange how my homeworks and quizzes work, how I assign them, but at the end of every week, because I like people to absorb things before they have to do problems on them. So basically at the end of every week, except the week before a test, but most weeks, at the end of it, you'll have a homework based on what we did that week, right? So basically, on Friday, you have a homework based on what we did do today and Thursday. It'll typically be posted on Friday. Sometimes it's Saturday, but most of the times on Friday. But whenever it's posted, you have a week to do it. So basically, if I post it on Friday, it'll be due next Friday. If I post it on Saturday, it's due next Saturday. But most of the time, it'll be on Friday. So you'll have a homework. You'll open it up. You'll do it, and then you'll submit it. And after you submit it, it'll tell you what you got right, what you got wrong, and also the correct answers for the ones you got wrong. The second attempt, you have 3 attempts, by the way. The second attempt is the same problems, but different numbers, right? So basically what you can do is use your first attempt, go back through it, try to figure out what you did wrong to get the right answer from the first attempt, and then do the same thing that you did to get the right answer on the second attempt, right? Hopefully you get more questions right. The second attempt, then there's a third attempt, so if you still get questions wrong, you can do it the third time. Hopefully by the third attempt you have all the questions right, so you can get all the extra credit, right, for the homework. So like I said, the homework is hard, but you can go to my TAs when I have them. I don't know who they are, but when I get TAs and they have tutoring, I'll tell you what they are. You can go to TAs for help for the homework. You can work with classmates with the homework. I don't mind that if you get in groups. The other thing is that the review session that I mentioned at the start of this syllabus is designed to be just a sort of a small little section where people can optionally come and just ask me questions, but it always boils down to how do you do the homework. So the review sessions are basically homework hints. They're always basically homework hints when the homework's due. And I post the work from the review session is also posted on Canvas, right? So that will help for the homework, right? But so basically what I'm saying is if you work at the homework and you go to the tutoring and you watch or come to the review sessions, then you should be able to do all the homework and get all the points that you can, right? Okay. So, like I said, there's also quizzes. So quizzes are, oh, by the way, after the homework's due, I post the homework solution. So the homework solution is the homework done step by step in a PDF, but it's also a video that explains the steps, because sometimes if you just read the PDF, you miss some things. So there's a video too that amazing amount of people don't know exist, even though it's right with the notes. That basically walks you step by step through the problems, right? So what I'm trying to say is even if you don't know how to do the homework after it's due, you look at the homework solution, and that should show you how to do every single problem step by step, correct? Okay, so then there's a quiz. So after the homework is due, it's a little bit strange, and you have to get used to it, but people do get used to it pretty quickly. But after the homework is due and the solution's posted, then I give you a quiz, right? And the quiz is like a mini test. That's basically what it's designed to be. So for example, this Friday, I might give a homework. It'll be due next Friday. And then after that's due, I'll give a quiz, probably on Saturday, right? So, but it'll be available for a few days because it's not just Saturday. It's probably due like Tuesday, Saturday to Tuesday. But the quiz is like a mini test in the sense that it's timed. So you don't have an infinite amount of time to take it, because for a test, you don't have an infinite amount of time to take a test either, right? Any test, right? So the quizzes are like mini tests. They're timed. You have one attempt. It's not multiple attempts, just one attempt, right? And it's timed. So when you start it, you have to finish it when you start it, right? Now the quizzes are meant to be easier than the homeworks, although some people argue that's not the case. But I would argue that if you think they're hard, it's probably because you don't know the material well enough, which is a red flag. It means you need to study more for the tests, right? Okay, so if you know what you're doing, the quizzes should be far easier than the homeworks, right, is what I'm trying to say. And it's good to test yourself before the test, right? Because if you don't know what kinds of questions that could be asking on the test, you don't know exactly what you know or don't know. So the quizzes are designed for you to figure out what you know and what you don't know, so you can study accordingly for the test, right? And if you study well for the quizzes, you have to study less for the tests, right? So that's what the quizzes are for. Now, after the quiz is due, so when you take the quiz, you'll see your score, but you don't see what you got right or wrong. However, after the quiz is due, you can go back and see what you got right or wrong, right? And then after the quiz is due, I also post a quiz solution with the notes and an explanation video of how to do the quiz. Okay, so that's how the quizzes work. There's a little typo here. I had the percentage of the grades wrong, but it's what it says here, right? That's the percentage. Okay, so that's the quizzes. Okay, so I just want to say one more thing about the quiz. The quizzes are one shot, right? So basically you have one attempt at it, multiple attempts at it. So some things can happen when you're taking the quiz. Your internet could go out, your computer could die or whatever. So you don't want that. I mean, you want to charge your battery before working on a quiz or have it plugged in. But sometimes you have a power outage or you lose internet. So if that were to happen when you're taking the quiz, you could get a 0 because it could kick you out and then submit your work, which is nothing. So if that happens, you can email me. I check to make sure that you did get logged out. I can check that. And then if that's true, I can reset your quiz. You can have another shot at it. However, this whole process takes some time. You have to email me. I have to see the email. Sometimes I don't see emails. I don't see them immediately. So then I got to go to Canvas, reset you, which takes some time. It's not so obvious. Should be easier to do in Canvas, but it's not. And then I have to email you that it's reset, then you got to retake it, right? So this whole process takes some time. So basically what I'm saying is you should take the quiz way before it's due, just in case this happens. If you take the quiz an hour before it's due, and you get kicked out half an hour before it's due, you're not going to have time to take it, right? Or this whole process to work. So I don't even respond to emails. Some people say I don't respond to emails. No, I don't respond to these kinds of emails. If you email me like an hour or 2 hours before it's due, asking to reset the quiz, I can't do it in time, so I don't answer. But if you email me way ahead, like 12 hours ahead the day before, and then I'll reset it and you can do it again, right? Does everyone understand? Okay, so that's one thing. The other thing is for any sort of Canvas work that you submit, you should always save a copy, either as a PDF or print it out. In other words, if you submit a homework and you get some points on it, print out the result of that. If you submit the quiz and you get your quiz score, print it out. Because every once in a while, Canvas doesn't record something that you do, right? So you might take, it doesn't happen that often, but you might take a quiz, you get a 90 on it or whatever, and Canvas doesn't record anything. So you need a printout of that. If you have a printout of how you did on that quiz and you show it to me, I can manually enter the grade, right? So you should always keep a record of every assignment you submit too. Yeah. Yeah, the PDF works better if you can do it. But yeah, some proof, right? All right. Okay, so this is how the test will work. So I'm changing the test slightly this semester. It doesn't really matter much. I give a test. The test is graded. If it's a slightly different test than a previous semester, it doesn't really matter much. But I am changing something with the test this semester. In previous semesters, I had a multiple choice section and a written section where I graded partial credit on some problems, which is great, and I like doing that. But there's so many students. They increased enrollment in this class last fall, and there's 350 students between these two classes. It's pretty hard to grade multiple written questions step by step. So I'm changing it a little bit, although there is some partial credit I'll explain. So I'm still narrowing down how many questions. There'll be approximately 25, give or take a couple, somewhere in that range, right? It's not going to be like 35 or 50. It's going to be around 25. And most of the questions will be simple. Simple if you know what you're doing. Of course, simple is relative. The less you know, the harder it is. But the more you know, the easier it is. Most will be simple questions, meaning short calculations, meaning 1 or 2 step calculations, not that hard if you know what you're doing. Definitions of things we talked about, and concepts, right? That's most of the questions. However, the last 4 or 5 questions, I'm still deciding whether it's 4 or 5 questions. The last questions would be the hardest questions, meaning they're the hardest questions. Like you have to think about them a bit. They might be more than 1 step, right? So they're harder. However, for those questions, what you got to do is show your work for those questions. And if you get those questions wrong, we'll grade those questions, the work for just those questions, as partial credit, right? So if you show your line of thought, you can get some points for the harder questions, right? And that's what I'm going to try this semester. Makes it a little bit easier to grade. If you get the question right, you just get it right. I'm not going to check your work, right? If you get the multiple choice question right, that's what I'm trying to say, right? Okay, so does that make sense? The other thing I should mention for the test is that you should bring a pen because the multiple choice answers have to be marked in pen, which I'll explain in a minute. It's not a Scantron, in case you're wondering how Scantrons work in pen. It's not a Scantron. And the written work for just the last 4 or 5 questions has to be in pen. You can use a pencil for everything else. We're not grading partial credit in all the questions, right? Just the last 4 or 5. So if you want to use a pencil to do all the rest of it, it's fine. But you need a pen to do the last 4 questions and mark the answer key. If you don't bring a pen, I take off points, right? So I don't take off that many points the first time because maybe people forget. But I'll tell you when the first test comes around again. And I'm telling you right now, right? Bring a pen. And then I tell you every test to bring a pen. So if you keep on not bringing a pen on the 3rd, 4th test, and then I take off more and more points, right? So hopefully everyone does it on the first test and no one does it on any other test after that. Yeah? No. Prefer not red, but any other color is fine. Okay, so for test, and I'll go over this when we get closer to the first test. Again, the only thing you need to bring for the test is your ID, so I know who you are when you turn it in. You're going to show us your ID. A pen or pencil. No, pen and or pencil, right? You guys. You need the pen. You could bring the pencil if you want. And a calculator. It doesn't matter what calculator. Any calculator you know how to use, but know how to use it, because it's another problem, is people don't know how to use their calculator. So you gotta make sure you know how to use your calculator before the test. So I don't do Scantrons, but I provide you with an answer key. That's one thing, right? So you don't need to bring anything as far as Scantrons go, right? I give you an answer key. There's also an equation sheet with the basic equations for that test. That'll be provided with the test. In fact, the equation sheet will be posted on Canvas about a week before the test, so you see what equations are on the equation sheet before you see it on the test. However, you don't bring the equation sheet with you. It's stapled to your test. I also give you blank paper so you can use it for scrap, right? So does everyone understand? All you need to bring is a pen, calculator, and ID. Okay, so everyone knows to use a pen, right? Okay, good. We're almost done, and then you can take the break. All right, so this is one thing, because this gets pretty annoying sometimes, but it actually doesn't matter that much anymore because the withdrawal date is so late in the semester, but I don't know if people understand this or not. So if you're doing poorly, I'm not saying if you have a B plus or something, you're looking to get an A or something. I'm saying if you're failing the course, right? So what happens is a lot of the times no one shows up to class, which I'll go into in a minute, class attendance in a second. But not many people show up, not many people come to my office hours. It's just how it goes. I think it's typical of most classes. And I don't really know anyone, or I don't know many people. There's some people I know over the course of the semester, but a lot of people I don't. And then, some people show up to my office hours at the end of the semester, with like 2 or 3 weeks left in the semester, that are failing, and they want to know how they changed their grade. So to not get an F. But there's this inertia with the grade, right? If you're failing through 2/3 or 3/4 of the semester, 90% of the semester, it's mathematically impossible to change your grade in that short a time frame, right? So it's just a waste of time, but it always happens. I always get all these students I've never seen before in my life come to my office hours at the end of the semester asking how they can improve their grade. So it doesn't work like that. You just can't do it. It's mathematically impossible, right, to change your grade by that much in so little time. So I have this honor. You just don't come to see me, right, after like November 7th, which is basically 3/4 of the way through the semester. If you have less than a C. If you want to talk to me, if you have a B or something, and you want to see what you need to do to get an A, all right, that's fine. But if you're failing, don't come, because it's just a waste of time for both of us. You're wasting your time and my time. So don't do that. Cheating, so don't cheat. Cheating is actually pretty serious. I mean, I think it's kind of serious, but they're trying to get more serious. You should actually read the Code of Academic Integrity here. There's a hyperlink when I post it on Canvas. Because it's actually, I think, more serious than I think people think here. Basically, if you get caught twice, you're expelled. And one time goes on your transcript, right? Which is not good to have on your transcript. So we have proctors walking around, and people still try to cheat. So, just don't cheat. We look for it. So the other thing I should say is the homework you can work together, but the quizzes are supposed to be individual. They're supposed to be mini tests. You should approach it like a mini test, meaning that you shouldn't work with other people for the quiz. For the homework, it's fine. For the quiz, you shouldn't. Quizzes online, so it's pretty tough to monitor, but I can figure things out every once in a while. If I can figure things, can tell that people are taking quizzes together. I can bring that up and we can talk about it. So don't try to work with other people on quizzes, right? Okay, so all right, there's a couple more things. There's 2 things I want to say. One's the final, and then one's the attendance, and then actually 3 more things. Sorry, there's 3 things, and then you guys can take your break. So The final is optional. So basically the idea is after every test, I post your averages, meaning your quiz average, your test average, and this thing called your overall average, which is basically your overall average. It's exactly what it says. It's the average factoring all the things in using this grading scale here, this scale. So at the end of every test, I update this, right? So throughout the entire semester, you know what your overall average is. By the way, there's this other column in Canvas that says total or something like that. I'm not sure if it's total, but anyway, the thing is completely meaningless for this class. So you just ignore total and pay attention to what I post, which is the overall average, right? It'll be up there after the first test and updated as the semester goes along. Anyhow, the point is, if you're happy with your overall average through the fourth test, right? Then you basically don't take the final. That's how it works. Easy as that, right? So you have an A after the fourth test, that's it, you're done, right? If you have a B, but you're fine with a B, then you're done. If you want to take the final is hard. I'm telling you that right now. It's a lot harder than a test. And it can affect your grade either positively or negatively. It can increase your average or lower your average. But it's up to you if you want to take it. But I suggest you just get an A in everything and then don't take it. And then it's an easy choice. You're done. There's one weird thing about the final. The final is cumulative and it's hard. So if you somehow get an A in the final, it means that you really know what you're doing because you're acing a hard test. So you actually can get an A in the course if you just get an A in the final without doing anything else, theoretically. Although I don't suggest that. Although some people have tried it before. It's never worked, ever. But yeah, some people just haven't shown up for anything and then just show up for the final, but they always just bomb the final. So I wouldn't suggest that. But yeah, I mean, that's something that could happen, right? It's a slim possibility. So let me move this down. This got messed up here. Okay, so this is how you convert your overall average from a numerical grade to a letter grade. So the main thing is an A is 91.5 or higher, right? So I'll say something about that in a second. The thing you want to avoid is a 72.5 because that's a C. You want to get higher than a C typically. Most majors want you to get at least a C. I will say that so there's extra credit based from the homework, right? There's also extra points on everything. So basically, if you didn't do any extra credit, the tests are more than 100 points. So there's extra points built into everything, including the quizzes. The quizzes are also more than 100. So what I'm trying to say is if you got, theoretically, this has sort of happened. If someone gets perfect scores on everything, never missed a question on anything, your overall average would be something like 108 or 110, right? That's how many points are really there. And you only really need 91.5 out of like 108 or something, right, to get an A. So it's not so hard. It seems hard, but it's not hard to get an A, right? Trust me. You should see the percentage of people that get A's. It's kind of strange. But anyway, so it's not so hard. It looks into the beginning, but it's not, right? So just, try to do your best throughout the whole semester. Okay, so the other thing, I don't scale because of that, by the way. But the other thing I want to say is class attendance. So I don't take attendance, even though I'm supposed to take attendance, but it's college, so I always think taking attendance is kind of dumb. But for college, that is. I didn't mention that there's a screen capture program running right now. So basically there's a mic here. So basically everything I say and everything you see on the screen is recorded and it's posted, made into a video and posted on YouTube along with the notes and the PowerPoint and everything. So in Canvas, you'll have a YouTube link. It's not a public link. You get it through Canvas, but at the end of every class, I post the lecture. So it's sort of like a hybrid online class. And most of I know how it goes because I've taught it year after year. But most people just want to do it online, which is sort of fun because it's actually sometimes better for people. Some people are really good at physics and don't need to see things. explained in such detail. They just want to fast forward through things, which is fine. Some people are the exact opposite. They need to see things really slow, and they want to pause it all the time. So sometimes the online thing is better than coming to class, right? So the only thing you really have to be here for is the tests, right? But you have to do something, right? You can't just like not come to class and not watch the YouTube videos. It's one or the other, right? Because I mentioned things in class, right? And you need to watch the videos, right? So yeah, if you don't want to come and you want to watch it online, it's fine. And the other thing I say is that if you want to come to class, it's better if you pay attention than doing something else, right? So if you're working on your laptop the entire class, I don't quite understand it because the video is on, the lecture is online, right? So if you have work to do that you need to do on your laptop, you can just go to the library and work on your laptop. There's no reason to spend the entire class on your laptop or on your phone. If you want to talk to someone on your phone or text someone on your phone, you can go some other place and then watch the video later, right? So if you come to class, try to pay attention, right? And if not, just watch the videos online. Yeah.
By when are the videos going to be out?
When I get home. So I have to go, after this, I have to drive home, and then I have to upload them, and then they're posted. Are there any questions on this?
Do you mind if we record it for a year, or is it?
It's fine, but I mean, this microphone does a pretty good job. Yeah, it's the same thing. Any other questions or anything? Yeah. You don't know. I mean, so the links are in Canvas. Mm-hmm. Yeah, no, we're going to do trig. So after I'm done with questions about the syllabus, we'll take a break, and then after the break, we'll actually do some trig. Yeah.
What's the name of the room from the earlier class?
SO 250? Yeah. It's a horrible room, though. Really bad. I don't like teaching in there. All right, any other questions? All right, so take a 10-minute break. Come back at about 5, 6 past 8, and then we'll do some material, right? All right, so I'm going to start the video. So let me say something before I start. So I have these PowerPoints, and the PowerPoints are kind of part of the text for this course. So they're kind of wordy. There's a lot of words on some of the slides, but that's the point. I'm trying to explain, the theory and stuff. So, everything that you see on the screen is going to be put on Canvas, all the PowerPoints, all the notes. So the point I'm trying to make here is that you shouldn't really write much, right? You should just sort of pay attention. Especially don't try to write all the PowerPoint slides, you'll never do it. So just sort of pay attention, listen to what I'm saying, try to absorb things, make little notes to yourself if you need to make little notes to yourself, but you shouldn't actually write down everything, unless you need to do that. Some people need to do that to reinforce the idea, I guess. But otherwise, just sit there and sort of just listen. Okay, so that brings me to my first PowerPoint here. So we're going to basically do the trigonometry review this class, and then start the next thing, proportions, which we'll finish on Thursday. And then on Thursday, we'll also start doing some physics on Thursday. Before we do that, we're going to do some math, right? So we're going to just do basic trigonometry that you need to know to do the physics here. So some of you have had trig, probably most of you had trig. If you had trig, it's a little bit boring, but it's a good sort of refresher, so you know it when we start using it. If you haven't had trig, then you probably want to pay attention because you need it for physics, right? So it's just a simple trig. It's not anything crazy complicated, but we'll see how it goes. Okay, so trigonometry is basically the study of triangles. That's literally what it means. So particularly in this class, we're going to focus on right triangles, right? So basically any triangle can be made into a right triangle or multiple right triangles. So even if you don't have a right triangle, you can still use trigonometry. Now, but for this class, we're focusing on right triangles. So here's a right triangle, right, where one angle is 90 degrees, and you have three sides of a triangle, A, B, and C. So C is usually the hypotenuse. A and B could be flipped, and this side could be A, this side could be B, this side could be A, or vice versa. But nonetheless, there are three sides. And then you have two angles that are, they can be anything inside those, this triangle, right? This is 90 degrees. So you have these two other angles in here. This is called theta. It's a Greek letter, theta. It's typically what we use to represent an angle. It's a typical thing we use to represent an angle. But if there's more than one angle, we sometimes use phi, which is this other Greek symbol, to represent another angle. But those are just two different angles, right? This thing called theta, this thing called phi. They're Greek letters, right? So the goal of trigonometry is using the angles and sides to find other information about the angle. We'll see other information about the sides or angles, which we'll see how that's done in a minute here. But before we get to the trigonometry, there's actually a little bit of geometry you should know about right triangles too that comes up in physics. Particularly that if you have a triangle, the three angles inside a triangle always add up to 180. Most of the time. I mean, for what we're doing in this class, let's just say that. So, because this one's 90, it means these two angles are complementary, which means they add to 90 degrees. So, if you know one angle, you automatically know the other angle, because they both add to 90. If this is 20, then this is 70, right? If this is 50, then this is 40, right? So what I'm saying is if you know one of the angles, you automatically know the other angle, because they add up to 90 degrees. That's one thing you need to sometimes pay attention to. The other thing is just pure geometry. If you know two sides of a triangle, you can always find the third side of a right triangle by the Pythagorean theorem. This side squared is equal to this side squared plus this side squared. So if you know two out of the three sides, you can always find the third side using the Pythagorean theorem. So that's not trigonometry, that's just geometry, but it's something you should know. Now we're going to get into the trigonometry. So the trigonometry is used when you can't use geometry to figure things out. So one example would be, suppose you know this angle and you know this side, the length of the side, right? How long that side is, and say this angle. And you want to find how long this side is, or how long the hypotenuse is. You can't do that with geometry. The Pythagorean theorem doesn't help. And nothing else in geometry helps. The only thing that you can do is trigonometry for that situation, right? So basically what I'm going to explain in the next few slides is how you, the theory behind trigonometry. And then when we're done doing a few slides, I'll do examples step by step in the notes here, and you'll see how it works. Okay, so we're just going to deal with these three main trigonometric functions. There's more trigonometric functions than those, but these are the ones we're going to focus on because these are the most important ones for physics, or applications of physics, which is cosine, sine, and tangent. So we're just going to do them in that order. It doesn't matter what order you do them, but I'm doing them cosine, sine, and tangent. So you have this triangle here, right? So you have two angles inside the triangle. And cosine is related to one angle or the other angle, which I'll explain in a minute. So I'm going to do it in general. I'm going to say the angle is x. X can be theta, x could be phi, x could be some other angle, right? And you're trying to figure out what the cosine of some angle x is. The cosine of x, right? This is cosine, by the way, the shorthand notation for cosine of an angle x, is just literally defined to be the length of one side divided by the length of another side. In this case here, it's the length of the adjacent side divided by the hypotenuse. Now the hypotenuse is always this side here. It should be easy to find, right? C, length C. Side C is the hypotenuse. Now the question is, what is the adjacent side? All right, so that depends on what angle you're talking about. For instance, you could talk about this angle here. You could say, what's the cosine of that angle? Well, the cosine of that angle, theta, this one, is the side that's adjacent to that angle divided by the length of the hypotenuse, which is C. The question is, what is the adjacent one? Is it B or A? There's two other sides there. Okay, so the way it works like this. The angle, theta, right, goes from the hypotenuse to this. We say it spans these two sides, but it goes from, if you're defining theta, right, it's the angle between here and here, right? So the side that makes up the angle is the adjacent side, right? This is the adjacent side to this angle here. This is what we say is the opposite side. The opposite side to theta, this one, is A, right? We'll see opposite in the next slide, but for now we're just worried about the adjacent. So the cosine of theta is literally the length of side A divided by the length of side C. It just gives you a decimal, but that's what it is. That's what cosine is, right? So the question is, why do we do that? It's because you can use it to figure out lengths of sides. For instance, if you multiply, so cosine theta is the adjacent side over C, which is B over C, and then if you multiply by C, just algebraically, you get the B, the length of side B, is C times the cosine of theta, correct? So if you know C and you know the angle, you just plug that in your calculator and that gives you length of side B. So there's these buttons on your calculator, cosine, sine, tangent. So you plug them in into your calculator, 30 degrees cosine, and then you multiply it by C, and that'll give you the length of side B, right? We'll do examples of this in a minute, but that's how you use it. However, the thing that confuses people sometimes is, what if you're talking about angle phi, this angle here, right? Then things change because this, phi goes from A to C, right? So side A is adjacent to phi, and side B is opposite of phi. So for phi, the cosine of phi is the length of side A, because it's adjacent to it, divided by the length of side C, right? Which is what I wrote here. So once again, you can multiply by C, for instance. You can find out what side A is. It's just C times the cosine of phi, right? That's the length of side A. All right, does that make sense? That's all cosine is. All right, now we're going to go into sine. So sine is the same thing as, well, not same. It's similar to cosine, but it's not adjacent over the hypotenuse. It's the opposite side of the hypotenuse, right? So I talked about the opposite side in the last slide, and you use it for sine. It's one of the things you use it for. So for instance, sine of this angle here, theta, the opposite side is this one, which is side A. So the sine of theta is equal to the length of side A divided by the hypotenuse, which is C. Yeah?
Is the sine of phi and theta arbitrary? Because they're the same, the angles are the same size, right? Because it's a 90-degree triangle.
No. They're related in the fact that they add to 90 degrees, but they can be anything. They're not necessarily 45, for instance.
Oh,
Right? They can be any combination. Okay, so sine theta, right, is the opposite side, which is A divided by C, right? That's what sine theta is. So if you want to find A using the sine of that angle, you just multiply by C, you get A is C sine theta. And you say, well, why do I want to find A using sine? I can find A using cosine if I do this, right? A is also equal to C cosine phi. Well, it turns out that the cosine of phi is equal to the sine of theta if they add up to 90, right? So if two angles add up to 90, the sine of one of them is the cosine of the other one. That's just how it works. So it's two different ways of doing the same thing is what I'm trying to say. But that's how you define sine, right? That's how it's defined. All right, so the other thing is, what if you're talking about this angle phi, right? So you're trying to find the sine of phi instead of theta. So for this angle here, B is opposite, right? So the sine of phi is the length of side B divided by the length of C. So that gives you the sine of phi, and then if you multiply by C, you get B is C times the sine of phi, right? So that's how you would use it. All right, the last one is tangent. So there's two ways to define tangent. We're focusing on the first way, but there's another way to do it. The one we want to focus on now is opposite over adjacent. So the tangent of some angle is the length of the opposite side divided by the length of the adjacent side. By some algebra, you can also show that it's sine over cosine, but don't worry about that. We're going to focus on opposite over adjacent, right? So for instance, you can talk about theta, and you can say, what's the tangent of theta? Okay, so the tangent of theta is the length of side A, which is opposite of it, divided by the length of side B, which is adjacent to it. And for phi, the tangent of phi is the length of side B, because it's opposite of it, divided by the length of side A, right? So the tangent of phi is B over A. B over A. Tangent of theta is A over B, right? And then you can use that to find the sides too. For instance, you could find side A. If you multiply both sides by B, you get A is B tangent theta from the first equation. And you can do the same thing for the other one. If you multiply by A, you get A tangent phi is equal to B. Now, that's something you can do with tangent. The more useful way of using tangent is actually using it to find angles. So if you know side A and side B, you can use tangent to find the angle, what theta is, as a as an angle in degrees. So we know that tangent of theta is a over b. I just explained that, right? That's what I wrote here. If you do something called the inverse tangent, right? So there's a button on your calculator. It's inverse tangent, not tangent. It looks like this, tangent to the negative 1. If you take the inverse tangent of a over b, that gives you the angle of theta, right? That's how you can use it to find angles. You can't use geometry to find angles like that. But you can use trigonometry to find angles, right? That's another use of trigonometry. Now, this means absolute value, and you're saying, why is there an absolute value there? Because these things are, sides are positive, right? I mean, you don't have negative lengths. Lengths are positive, right? You don't have negative lengths. However, actually, when we do applications to physics, the lengths can actually be negative, which is kind of weird, but we'll get to it. When we get to it, I'll explain it. And if the lengths are negative, you ignore the negative signs, and you just use absolute value, right? And absolute value means you ignore negative signs. What we're doing today is just normal sort of triangles with positive lengths, so we don't worry about that, right? All right, so does that make sense? So this is what we need to know to do the physics in a couple weeks. There's also this device, however you say that, mnemonic device, that you use to memorize how these equations go, right? So it's SOHCAHTOA, so meaning sine is opposite over hypotenuse. The next part is cosine is opposite over adjacent. Adjacent over hypotenuse is what I meant to say. And then the TOA is tangent is opposite over adjacent, right? So this is what you can use to sort of memorize what sine, cosine, and tangent are, right? All right, so does this make sense so far? Does everyone who hasn't entered kind of get it? Well, we'll see if you get it when we do some examples. So now I'm going to go to the notes. I'm going to try to sit down because I can't write standing up that well. Although I can write in the seat because it's too low, but we'll see. All right, so like I said, people try to write down all these examples, which is fine, I guess, if you want to do that. But if you just kind of just pay attention, because it works better if you just pay attention and just watch, right? Just think and watch. Okay, so I have this triangle already sort of written, right? So this is how you write theta, right? Theta, basically how it sounds. So this is theta, this is phi, this one. So you have these three sides. So this, suppose we're given that this side is 3. So 3 units long. It could be like 3 feet. It doesn't really matter. It's just 3 units long. 3 inches, it doesn't matter. And suppose we're given that this angle, I'm going to move it out so I can write here, is I think 32. I remember it from the other class, but I'm going to look it up in a second. But I think it's 32 degrees. Yeah. So this angle, I'm just trying to write it, 3. Anyhow, 32 degrees. If you can't read that, it's 32. It's supposed to be 32. Okay, so this is what you're given. You know the length of side A, and you know that angle is 32, right? Theta is 32. So the question is, we're going to do a few parts to this triangle, for this specific triangle. So the question is, what's the length of side B? So this is sort of a typical thing you do with trigonometry. Okay, so for physics or for this sort of math problem or trigonometric problem, it's the same basic idea, even for physics, right? So basically, you're given some information, and you're asked to find something else. So basically, what you need to do for physics or math is figure out how you're given information relates to the thing that you're trying to figure out, right? So let's see what we're given. Well, we're given 2 things, right? Theta and A. So the question is, how does side A relate to the other thing that we know, which is theta? I mean, is it the opposite side? Is it the adjacent side? Is it the hypotenuse? A, the thing that we know. How does it relate to the other thing that we know? It's opposite, right? Because theta faces, side A faces theta, right? All right, so that's one thing we're in. So side A is opposite of theta. And, okay, so then the other thing we needed to do is figure out how the thing that we're trying to find relates to other information that we know. So specifically, how does side B relate to theta, right? Which is something, so side B is the thing we're trying to find, but we want to relate it to something else that we know, right? So how does B relate to theta? Right. Okay. So we have the things that we know, the things that we don't know, we want to relate them with something, with some equation, right? So what do we use here? Yeah. So we use tangent, because tangent is opposite and adjacent in it, correct? Okay, so let's write that down. So tangent of theta. So that's, in general, opposite over adjacent, right? But opposite is A, adjacent is B, right? So that's what you write down, right? So tangent theta is A over B. And then what we got to do is find B, right? That's the question. So how do you find B? The first step is you want to get B sorted by itself. So what you need to do is multiply by B first, and that gives you B times the tangent of theta is equal to A. That's not what we want. We want to find B, not A. We know B. We know A. We want to find B. So what do you got to do to find B? Right, so it's just A divided by the tangent of theta. So this is 30. And it's a little bit messy. I like to sort of line things up so it looks better. But anyhow, so B is 4.8. Okay, so there are things that call significant figures, which you learn in lab and stuff. I don't really care about significant figures because there's a lot going on. And what I care about is, can you do the physics and get an answer that's pretty close, right? So I usually just do things to do decimal points, right? I don't really care that much about significant figures, right? So it's 4.8, right? About 4.8. All right, so does everyone get that? The other, you should try to get this answer on your calculator. Make sure you know how to use your calculator, right, with trigonometric functions. All right, so does that make sense? Okay, so the next part is B. Okay, so the point of this, which I'll explain in a second here, is that we know, we figured out B, right? And we know A. So there's a way to get C, using B. But I'm saying, suppose you don't know what B is, right? Suppose this is what you're given. You're given what side A is, what this angle is, and you're just trying to find side C just using that information, right? So that's how we're going to do it. Okay, so let's do this again. So how does we know what side A, how side A relates to theta. It's the same as part A, right? So side A is what again? In relation to theta, what is side A? One more time. Opposite. So what is side C all the time? Hypotenuse, right? So I'm going to borrow this, but change it. It's not the same thing, but it's pretty close. Okay, so side A is opposite, and side C is the hypotenuse, right? All right, so what do we use? So we need something that relates the opposite and hypotenuse, which is what? Sine. Right, so we're going to use sine. So the sine so the opposite side. So sine theta is A over C, correct? So we're trying to find C. So the first thing you do is multiply by C. But that's not it, right? Because we want to find C. So how do we find C? Right, so it's A divided by sine theta, which is 3, divided by sine of 32. So C is 5.66 about. Right, so that's how you do that. Of course, there's another way to do it. In fact, for math and physics, there's usually more than one way to do everything. Actually, if you can do it more than one way, you get the same answer both ways, then you're probably doing something right, right? So the other way to do it, you could just use the Pythagorean theorem, right? Because if you know what A is, you know what B is, then you can use the Pythagorean theorem. So it's 3 squared, because that's side A, plus side B, which is 4.8 from part A. The square root, and you get the same thing, right? So this is what I'm saying. If you can do things more than one way, get the same answer. Doing it more than one way means that you're probably doing it correctly, right? Okay. Okay, so this is pretty straightforward, but a lot of people forget this and they think about it, too complicated. So the question is, what's the angle phi, which is this other angle here, right? So what's that angle? So does anyone see an easy, there's more than one way to do it, but what's the easiest way to do it? Right, so they're complementary, right? They both add up to 90. So if you know one of the angles, the other angle adds, when you add the other angle to it, it becomes 90. So the other angle is just 90 degrees minus theta. Was it 32? So it's 58. It's simple, but a lot of people forget how to do this, right? So make sure you know how to do this too. Okay, so theta is, phi is 58, right? The other angle is 58. All right, does anyone have any questions so far? Okay, so then I think there's one more part. Let me do a different triangle. Okay, so this is another sort of weird question. It's not that weird, but we're ignoring things that we already know. So the question is, find side B using only side A and phi, right? So suppose you only knew that phi was 58 degrees and A was 3, right? The question is, what is the length of side B, if that's what you're given, right? So in relation to phi, what is the other thing that you know, which is A? It's A is adjacent to it, correct? What is side B in relation to phi? Opposite. So it's opposite of what we did before. So tangent theta is A over B, but tangent phi is B over A, right? So it switches, right? You got to pay attention to what angle you're talking about. So anyhow, side A is adjacent to phi, and side B is opposite. So use, what are we using again? Tangent, right? I sort of went ahead. Actually, I'm going to borrow this and change it because it's kind of similar, but not really. Okay, so this time we're talking about phi though, right? So it's opposite over adjacent, but for phi, side B is opposite, right? And side A is adjacent. So it's B over A, right? Tangent to phi is B over A. Then we're trying to find B. So B is A tangent phi, correct? You just multiply by A, and you just plug in the numbers. So this is 3. Which is whatever B was, right? Yeah, it's 4.8. Oh, sorry, we're trying to find A, right? What was the question? Find side B, right? Wait, what are, A was 3, right? Yeah, 4.8. Is that? Yeah, that's right, right? 4.8. I don't know what I was thinking. Sorry, I was thinking get them reversed, right? I don't know what I was in, but that's right. 4.80, right? Okay. All right, so does that make sense? Okay, so then we're going to do another triangle, right? It's pretty similar to this one, but it has slightly different questions. Okay, so it's the same sort of thing. It says I'm going to change some things. Okay, so this time we don't know A. So A isn't given, right? We don't know what the length of side A is. We do know that side C is 10. And this angle is it's just some weird angle, right? This is 42 degrees, just some weird angle. So now the question is, find side A, using obviously this information, right? Okay, so once again, we do the same thing that we did. What is C all the time? The hypotenuse. What is side A, which is the thing we're trying to find in relation to theta? It's the opposite side, correct? Everyone understands what's opposite and adjacent. Some people don't understand that when I first started. Okay, so side A, sorry, did I say phi? I meant theta, right? I think I said phi, but I meant theta, right? Okay, so side A is opposite of theta, and C is the hypotenuse. So what are we going to use? Sine, right? So if we're trying to find side A, it's pretty straightforward, right? It's just one step. You just multiply by C. So it's 10. So the length of side A is 6.69. Right? That's the length of side C. All right, so does that make sense? Okay, so the next part is find side B only using theta and the hypotenuse. All right, so forget we know the answer from A. We don't know what A is, right? Suppose we don't know that. Okay, so for this one, right, what is side B in relation to theta? Adjacent, right? And side C is the hypotenuse. So what do you think we're going to use? Right, use cosine. All right, so side B is adjacent. So we're going to use cosine. So the cosine so it's B over C, right? So B, so it's going to be 10 times the cosine of 42. So this is 7.43. Of course, you can do this with the Pythagorean theorem, too. If you found the answer for A, which is 6.69, then if you take C, you subtract 6.69 squared, take the square root, you get the same answer, right? But this is how you do it with trigonometry. All right, so does that make sense? Okay, so we're going to do a third example with a third triangle. Okay, so for this one, we don't know. Okay, so A is back to being 3. C we don't know. B is 4. This angle, we don't know. So we know two sides, but we don't know any of the angles, right? None of them inside the triangle. So it's kind of different than the other one so far. Okay, so the question is, so what's this thing here, right? This angle here, theta, right? So once again, we have to relate what we were given, which is these two sides, A and B, to theta. So what is side say A. It doesn't matter which one we do first, but side A. How does side A relate to theta? What is it? Side A? Opposite, right? Side B is what? All right. So what do we use with opposite and adjacent? All right, we use tangent, right? There, I already did this, right? Somewhere. Here, right? I'm just going to copy this because I already wrote it down before, right? Okay, so once again, tangent theta is opposite over adjacent, side A is opposite, side B is adjacent, right? Okay. So now what we want to do is we want to find theta. So let's plug in what we know, right? So tangent of theta is 3 over 4, which is 0.75. But that's the tangent of theta. That's not theta. It's the tangent of theta. So the question is, how do you find theta, not the tangent of theta? Right, you have to do this inverse tan thing, right, on your calculator, meaning you have to take the inverse tangent of 3/4, or 0.75. And this gives you the answer, right? It's 36.87. Okay, so that's the answer, right? 36.87. Okay, so then the last part is pretty straightforward, but once again, how would you do phi? How would you find phi? What's the easiest way of finding it? There's more than one way. Yeah, so we did that before, right? Where is it? Here. This is the same thing, right? You just take 90 and you subtract the angle we just found, and that gives you phi. So what I'm trying to say is if you know two sides, you can use the Pythagorean theorem to find the third side. You can also use trigonometry to find all the angles, right, inside the triangle. So this would be 90 minus. So this is 53.13? Yeah. All right, so does that make sense? All right, so these notes are turned into a PDF and also put on Canvas, right? Which is why I say you don't really need to write anything. All right, so does that make sense? Sure, right? We're still going to do some other stuff. It's not quite done yet, yeah. This one? Except we're finding B, right? Yeah. Any other questions? All right, so now what I want to do is start the next topic. We're not going to do any more examples today, but at the start of class on Thursday, we'll do some examples with this stuff. So let me go back to the PowerPoint. Okay, so the next thing we're going to talk about is proportions. In this case, just mathematical proportions. But actually, we see proportions quite often in physics. They're basically a way to do calculations without redoing calculations. We'll see how it works when we do it in physics, but right now we're just doing it for ordinary sort of mathematical equations. So the simplest sort of proportion you can see is something like this, right? Y is equal to 2x or something, right? So it's just an equation. I don't know what y and x is. It doesn't matter. It's just to demonstrate proportions. So there's a number before the x, right? So this number doesn't matter when you're doing this thing called proportions. That could be a 2, it could be a 5, it could be an 8. It could be a negative number, it could be a decimal. It doesn't matter, right? So the number in front of anything, any variable doesn't matter when you're doing proportions. Okay, so this is called a direct proportion. The easiest way to see that is you basically just have y equals x, basically, if you ignore the number there, correct? Meaning that whatever x does, y does the same thing. And we're talking about changing x by some factor. It comes up all the time, this term factor. So a factor means you take x and you multiply it by some number or you divide it by some number. It's not adding anything to x. It's not subtracting from x. It's multiplying and dividing x by something. So if I say we change x by a factor, we increase x by a factor of 5, it means you take x and you multiply it by 5, right? You're taking x, make it 5 times bigger. I could say decrease x by a factor of 10. That means you're taking x and you're dividing it by 10, or making it 10 times smaller. That's what the factors are. It's not adding or subtracting, right? It's multiplying or dividing. The question is, if you take x and you increase it by some factor or decrease it by some factor, what happens to y? It does the same thing, right? If x increases by some factor, y increases by some factor. If x decreases by some factor, y decreases by the same factor. Pretty straightforward. It's the easiest one you can see. So if you take x and you multiply it by 100, increase it by a factor of 100, y increases by a factor of 100. If you take x and you decrease it by a factor of 20, meaning you divide it by 20, y goes down by 20, right? They just do the same thing, right? It's the simplest sort of thing you can see. Does that make sense? Okay. The next most complicated thing you can see as far as proportions go is if it's not just x, right? Here's x squared. Once again, the thing in front of the x, or x squared, or x cubed, whatever, doesn't matter. This could be a 20 or a 50 or a negative 100, doesn't matter, right? It's just, you ignore the number. But the point is, this is like y is equal to x squared, kind of, in some sense. So they're proportional in some sense, meaning that if x gets bigger, y gets bigger. But it's not just so simple. If you increase x by, say, some factor, y increases, but it increases by the factor squared, because it's x squared. If it was x cubed, it would increase by the factor cubed. If it was x to the 5th, it would increase by the factor to the 5th. If x, for this case here, if x decreases by some factor, then y decreases, but it decreases by the factor squared, because it's x squared, right? So in other words, if x, I have examples here, right? But, So if x, increased by, say, I don't know, 10, right? Then y would increase by 10 squared, which is 100, right? So if you increase x by 10, then y goes up by 100. If you say take x and you decrease it by a factor of 7, then y goes down, but it goes down by 7 squared, which is 49, right? So you take y and divide it by 49. Does everyone understand that? So you got to take into account these exponents, right? The next another example you can see is this example here, where you have the x in a denominator, right? So the difference between this example here is there was no fraction, right? Here there's a fraction. It's 4 divided by x, so it's 4 divided by x. X is in the denominator, right? Once again, the 4 doesn't matter, but where the x's matter. So just by common sense, if you take a number and you divide it by a big number, or a bigger number, what happens to that quantity? It gets smaller. If you take a number and divide it by a smaller and smaller number, what happens to that quantity? It gets bigger. So they're inversely proportional, meaning that if x does one thing, y does the exact opposite thing. That means, that's what it means to have inverse proportion. So, in other words, if x goes up by 20, you take x, you multiply it by 20, y goes down by 20, you divide it by 20. If x goes down by 15, y goes up by 15, correct? That's how the inverse proportions work. And you can have inverse proportions that are like this. So it's 4 divided by x cubed. Same sort of deal as this thing. So you have to pay attention to the cube. So once again, they're inverse proportions because the x is in the denominator. But it's just not a simple inverse proportion, right? You have a cube there. So basically, if x, say, increases by 5, then y would decrease by 5 cubed, right? So 5 cubed is 125. So if you take x and you multiply it by 5, y would go down, or be divided by 125, right? And if x, what did I just do? X go up? Did I just do x increase? Sometimes I forget what I'm doing. So if x decreases by 4, right? Then, so you take x, you divide it by 4, then y would increase by 4 cubed, right? So 4 cubed is 64, so y would go up by 64. You take y and you multiply it by 64, correct? All right, so then you can do things like this, because this happens too in physics. So you don't just have one thing changing by a fraction, you have, or a factor, I should say. You have two things changing by a factor. So this would be an example, like z is c times x cubed and y squared, where x and y both change by some factor. C is just a number, because in all these examples, because I just started them, I wrote a number. But you should know this number doesn't matter at all, right? So it could be, I already told you, it could be a big number, small number. So this number, this C just means it's a number, right? It could be any number. It just makes it easier to write down. Okay, so the point is, suppose you have this equation here, and x and y both change by some factor. And you're trying to figure out what happens to z, right? You're trying to figure out what happens to z. This is the equation. So the idea for these complicated ones is you do them one at a time. So for instance, z is proportional to x cubed, and you say, why is it proportional, inversely proportional? Well, first of all, there aren't any division signs there, right? So these are all proportional. But it's proportional to x cubed, and it's proportional to y squared, right? So as an example, suppose x increased by a factor of 2, right? So you take x and you multiply it by 2. That would increase z by what? 2 cubed, which is 8. So that alone would make z go up by a factor of 8, correct? Then suppose y, what am I doing here? I got to read this because it's tough to do it in my head because there's two things going on. Y increased by 4. So if y increased by 4, you take y, you multiply it by 4. What would happen to z? But if that's the only thing that happened. So z would increase by 4 squared, which is 16, right? So the two things are multiplied together because they both increase. So if it's an increase, you multiply, right? So x made z go up by 8. Y made z go up by 16. So the overall change is 8 times 16, which is 128. So z would be 128 times bigger than it originally was, if that's what you did. So this other example here, suppose you increase x by 3, right? So you take x, you multiply it by 3. What would happen to z if you make x 3 times bigger? You would increase by 3 cubed, which is 27. So that would make z go up by 27. But suppose you, instead of increasing y, you decrease y by 2, right? So if you take y and you decrease it by 2, you divide it by 2, what would happen to z? Right, it would decrease by 2 squared, right? Because it's the factor squared, because it's y squared, which would be 4. Because it's decreasing, you can think about it like going in, you divide, right? When things decrease. When things increase, you multiply. So the increase of 27 basically goes in the numerator, you can think about it. And the decrease of 4 goes in the denominator. So z would change, it would go up by 27, down by 4, which means the overall change would be 27 over 4, which is 6.75, right? That would be the overall change for z. So we'll do more of these things on Thursday and some examples in the notes too, so you see how it works. All right, so see you on Thursday.